Hello everybody, we're going to talk about the MA300 final project, and this is a brief guide, a brief on your final project, on what's being asked, where to find the data you need, and my expectations for completing this project successfully. First of all, to find the project, you're going to open Canvas, and in Canvas go under Course Modules where you'll find Week 10 Final Project Week, and under there you'll find Final Project and Data Set as shown down here at the bottom. Make sure that you open up this file to open up the final project itself and the data set that you're going to need to complete it. This recording will be found under lecture for week 10, and this presentation will be found under the background material for week 10, along with a Z table to help you complete some of your work if you're going to use the table. So the instructions are that you're going to download the document to your computer and save it. You'll find that the project name is the first one. Download this to your computer. When you save it, make sure that you change where it says name to your last name, please. This is going to make it easier for me to organize and return your work in a timely fashion. Also, you'll find the final project data set. This is a special data set for you guys. This is a sample data that is set up for this class specifically, so please make sure you take a look at the data set and we'll talk about what's in there. You'll be using Excel as necessary to get your answers, so you won't have to do a lot of calculation by hand right here, although you're certainly allowed to do all the calculations by hand to your understanding. The final project will be worth 20% of your overall grade. The data set itself is a Microsoft Excel spreadsheet that contains sample data about a particular class. We'll call it a statistics class. And in there you'll find, a student number right here. This is just an identification number on our first column right there. There's a column here for gender, where one is female, two is male. Age, GPA, SAT scores, the school, the year they are in school here, so we're at a pretend college and this is their year in school, the class section that they're in, the hours spent on study, final exam scores, project scores, and a political orientation right here where we go from -5 to 5, and it rates themselves from fully moderate or fully liberal to fully conservative. So take a look through the data set right there. Please make sure not to alter the data. If you need to reload the data set itself because you've done something, that's all right, feel free. That's why we've saved it to Canvas. So in this project, you'll have 5 questions to answer. From the project data set in Canvas, under the category Final Project Assignment and Data, the data set is in Excel, and you should use Excel to complete it. You should enter your answers and responses, graphs, charts directly after the question on the Microsoft Word document. So please, if you do some work in Excel, copy that work from Excel and paste it into the Word document. After you complete the project and save it, submit the project in Canvas. As you work for the project, be sure to save and email it to yourself to avoid losing your work. It's a very good idea to always back up your work. The project will require access to a Z table if you want to use that in Canvas, or you can find it in Table 2 of your textbook. Question 1 concerns correlations, scatter plots, and your prediction. You'll recall that we talked about this back towards the week 3 of the course. What we're dealing with right here is relationships between GPA and age. So the problem itself says which relationship is stronger, the one between GPA and age, or is there a relationship between the GPA and an SAT score? The best measure for this, don't forget, is to use your R value. If you recall, we talked about scatter plots and correlation, and an R value being the measure of this. So use Excel to help you compute this. It's kind of hard to do by hand. Also, you're going to be creating and pasting in a scatter plot that compares the final exam score with the project score, and telling me about the correlation between those two. And would you describe that correlation as positive, negative, strong, weak, medium, right? We could say that it was a strong negative correlation perhaps, or a medium positive correlation. Be sure to include a trend line and the equation of the trend line as part of your scatter plot. To review this, please go back and review that unit. The equation from above your scatter plot predicts or estimates a project score. So predict it for a person who gets a final exam score of 82, and be sure to show your work there. All right, in question 2, you're going to be comparing and describing data, and for this you're going to use the final exam score and then for the project score. And for each of those, you need to go through and calculate mean, median, mode, range, standard deviation, and variance. Make sure that you're using sample standard deviation and sample variance, since this is a sample data and not a population. After you've done this, decide which two numerical measures offer you the best information comparing the performance of these two assignments. Use the numerical measures to describe and compare the student performance between the final exam and the project, and be sure to tell me why. Don't forget, it's not just enough to say, well, we thought that the mean was a better measure. Why? Why do you think that's true? Which variable, the final exam score or the project score, has a greater variation of data? Make sure that you look your two measures of these two data sets, these two columns, and then choose the two numerical measures and use them to describe and compare the variation of the two variables. What do you think that variation tells you about student performance in each of these assignments? And finally, in the last part of this question, you're going to answer the question, who did better on the final exam? Was it males or females? Justify your answer using at least 3 numerical measures and a bar graph. Create a bar graph that will show the mean and the median values for the males and females. So in this particular one, you're creating a bar graph, 2 separate bar graphs, one for the mean and one that compares the mean and the median for males and mean and median for the females. In question 3, we get to relative and absolute differences, and that's where we're talking about 2 students here. Our fictional students are Sally and Ron, and they have to decide to go back to school. Sally's 28, Ron's 25. Based on their relative position, which of them, Sally or Ron, would be farther away from the average age of their gender group? Right, so we want to go back to the male and female here and compare them to those. Show all steps in your work, and hint, you're going to have to really calculate your z-score as part of this question. Recall what that z-score tells us in terms of the position of the number of standard deviations away from the mean. Remember, z-score is found by taking each person's age from the mean of their age group and the gender, and then dividing by the standard deviation for their group. So you're going to have to calculate each of these separately for the male and female students. Sally has a GPA of 3.35. Let's figure out what percentage of students have a GPA above her score, right? And show your work. And to do this one, don't forget you're going to calculate the z-score and then find your normal probability associated with that. Recall, this is how we find our probabilities under the normal curve, by finding the z-score and then finding the probability from our table associated with that. Or you can use Excel to do the same job. Also, you're going to talk about SAT scores, and they're normally distributed for 0 to 1600. And Ron's SAT score, what percentage of male students' SAT scores are below Ron's SAT? Again, use your normal distribution, use the z-score that you get right here, and find your probability from the table or using Excel to get this value. If you need help, recall what we did to find our M&Ms, right? This is kind of like our M&Ms, only this time we're using GPAs and SAT scores instead. In question 4, you're going to be creating you're going to be talking about frequencies and graphs, and you're going to be creating a GPA chart right here. So you're going to create a relative and cumulative frequency chart for your GPAs, and so we're organizing it by score: A, B, C, D's, and F's, using this breakdown over here. An F being from 0 to 0.49. A D being from 0.5 to 1.49, a C being 1.5 to 2.49, a B from 2.5 to 3.49, and an A from 3.50 to 4.0. You can do this by hand, or you can use Excel if you're comfortable. Remember that we used pivot charts to help us do that, and create a bar chart to show the frequencies of each of these letter grades. And finally, in question 5, you're going to be asked about confidence intervals. We studied this in Chapter 8. The data set for this project represents a sample data from a larger population. So we're going to use this data set to calculate a 95% confidence interval for the true population mean time that all students spend studying per week, according to the data. If the student spends 15 hours per week, we want to ask the question, is this significantly different from the population mean? And explain why you say so, right? Show all your work and use any Excel spreadsheet or tools that you need right here. You may use Excel. You may do this by hand. Remember, I have a confidence interval generator that you're allowed to use. Your job is to interpret the results here. In your own words, explain why and how sample statistics are used to estimate population parameters. Using a data set, create an example to support your explanation. So you can use exactly what we've just been talking about here from this data set and explain why that helps. Or you can choose to use a different set of statistics in this data set and use that as an example to support your explanation. Don't forget that this project is due no later than midnight on Friday, December 15th. I can't accept late work after this date because our grades are due, so try and get it in earlier rather than later. Please let me know if you have any questions and email me right away. That's all for now. Good luck, and I'll look forward to seeing your work in week 10.